Hi everyone, my name is Ayush. I will be giving an overview of the VQA Challenge 2020 and present some interesting analysis from this challenge. We are a growing community, so for those who are new to VQA, I will first recap the task definition in the VQA dataset. Then I will talk about some logistics about this year's challenge. Then I will announce the results, and finally we will go over some interesting analyses of the results. So let's start with the task definition. Given an image and a natural language open-ended question such as what is the mustache made of, the task for an AI system is to generate a natural language answer such as bananas. The VQA dataset contains more than 200,000 images from Coco, more than 1.1 million questions, and more than 11 million answers. In the VQA dataset, for every question, there are two images that look similar to each other, but the answer to that question for both images are different. For example, for the question, who is wearing glasses? The answer to these similar images are different, man and woman. So, the model really has to understand the subtleties about the image to answer the question accurately. The accuracy metric counts how many of the ground truth answers are same as the prediction. If 3 or more, the prediction gets full credit, otherwise it gets partial credit corresponding to number of ground truth answer it matches. That was about the task in the dataset. Now let us look at some details about the challenge. This year, the VQA challenge was hosted on Eval AI, same as the last 3 years. The training set consists of 80,000 images and 443,000 questions. The validation set is about half the size of the training set. The test set is about the same size as the training set. The test set annotations are not publicly released. Now let us look at the test set in more detail. The test set is divided into 4 splits of approximately equal size. The test depth split is for the purpose of debugging and validation. The test standard split is for public leaderboard. It has a limit of 5 submissions and maximum 1 submission per day. This set is also meant for reporting numbers in publications and comparing with other methods. The test challenge is the split used to decide the ranking of challenge participants. The test reserve split is used for making sure that there is no overfitting. Scores on this split are never released. Now it's time to announce the winners. But before I announce the winners, I would like to mention that this year we saw continued high participation with 25 teams participating in this year's challenge with individuals from more than 8 institutions. Now I am going to announce the runner-ups. This year we have 2 teams who jointly tied for the second place. One of the 2 teams is Renaissance at Damo NLP, and their team members are Ming Yan, Chenliang Li, Wei Wang, Bin Bi, Zhonzhu Zhao, and Sonfang Huang. Their challenge accuracy is 76.02. The other team at the joint second position is DL61, and their team members are Dalu Guo, Cheng Shu, and Decheng Tao, and the accuracy is 76.08. Now it's time for the winners, and the winner team is Movie plus Gridfeed, and their team members are Yukin Gwen, Huaizu Jiang, Vedanuj Goswami, Lecheng Yu, and Shinlei Chen. Their accuracy on the test split is 76.36. All winners will be given Google Cloud Platform credits. Now, I will present some interesting analyses based on the challenge results. This plot shows the challenge accuracies for all challenge participants. The green bar is the winning entry from VQA Challenge 2019. So, we can see that 4 teams were able to beat the winner entry of the last year's challenge. And there is a 1.1% absolute improvement in performance compared to the last year's winner. In order to find whether the performance of teams are statistically significantly different from one another, we performed Wilcoxon-signed rank test, which is a non-parametric version of the paired t-test. It tests the null hypothesis that whether two related paired samples come from the same distribution or not. We tested this for 95% confidence. This plot shows groups of teams that are statistically similar in same colors. We found that the winner team is statistically significantly better than the runner-ups. We also found that 61% of questions can be answered by all top 10 teams. We call such questions as easy questions, and 12.8% of questions could not be answered by any of the top 10 teams. We call such questions as difficult questions. Note that this percentage was 15.4% for last year's challenge. So 2.6% of questions that were difficult for models are decreasing over the course of years. We were also curious to know if there are questions that were difficult last year but are not this year. So we made this plot. In addition to making progress on how many questions, interestingly, the top 10 teams have also made progress on questions that require reading number-related text on images, such as what is the number, what number is on, and what number is the. Recall that the VQA dataset has two images with the same question but different answers, and these images are very similar to each other. We call these images complementary images. So, given such a dataset, it is interesting to analyze if the models are sensitive to subtle changes in these complementary images. So, in order to answer this question, we analyze whether the model produces accurate predictions for complementary images. We compute the accuracy of each model where the accuracy metric is how many complementary pairs it got right. Under this metric, if the model predicts correct answers for both images, it gets 1 point. Otherwise, it gets 0 point. So, we plot this graph and we can see that the top teams get about 68 to 73% of the pairs correct. We also see that the best performance improved by about 10% from last year. It has been shown by recent studies that today's VQA models are heavily driven by superficial correlation in training data. So, it is interesting to ask how much are the current entries driven by priors in training data. In order to answer this question, we compute the accuracy over those questions whose ground rule answers are not top 1 most common answers for the given n-gram in training. These questions consist of about 73% of the whole test challenge questions. In this plot, we show the accuracies of all entries for non-1 prior questions, and we compare this against the accuracies on all questions. We see that there is a drop of 5 to 6% in performance. Comparing this with last year, the best performance for non-1 prior questions improved by 1.3%. Another interesting question to ask is, how good are current models in answering questions that are compositionally novel? So, what we mean by this is that the test QA pairs are unseen in training, but the concepts in the QA pairs are seen. Suppose at test time the question is about red plate that you have not seen red plate during training, but you have seen a green plate and a red stoplight during training. So, by compositionality, I mean the ability to compose the concepts of plate and red to be able to recognize red plate at test time. Here, we look at the accuracy of teams for such questions. We see that the performance of all teams dropped by 11 to 13%. We also see that the best performance improved by 1.1% from last year. Thus, we saw that there is still room for improvement on this front, but we are making progress. We have been running this challenge for 5 years now. So let's zoom out a little bit and look at the progress in VQA. This plot shows the state-of-the-art performance on the dataset with time. Our baseline model from ICCV 2015 is shown at 55.3% and the human baseline is shown at 80.78. During Challenge 2016, the accuracy improved by 7%, followed by 2017 Challenge where the improve was of 6.7%, followed by Challenge 2018 where with 3.4% increase, followed by 2019 Challenge with 2.9% increase, and finally during this year's challenge the accuracy improved by 1.1%, going from 75.28 to 76.36, where the state of the art is right now. Understandably, the rate of improvement in performance is decreasing as we move closer to the human performance. However, we are still consistently making progress each year. That's all I have. If you have any questions, please join our live QA on 12 p.m. Pacific Time, June 14, or 12 a.m. Pacific Time, June 15. Thank you.